today we're going to talk about solving linear inequalities, which, as we'll soon see, is pretty similar to solving linear equations. The difference is, instead of an equal sign, our inequalities have inequality symbols. You might see one of the four symbols in these problems: the less than, greater than, less than or equal to, or greater than or equal to. Just to kind of quickly review, a true statement using the less than symbol would be something like 5 is less than 10, or -7 is less than -2. So let's start by solving some linear inequalities, and then we're going to graph our solution on the number line. So for the most part, the steps that you're going to take are the exact same steps you would take if it was an equation. So the goal is to get the x by itself. That means I have to start by adding 3 to both sides. And then to finish, to get rid of that 2, I'm going to have to divide both sides by 2. And that gives me x is less than or equal to 5. Now, we're asked to graph this solution set, explain what this solution set actually means on a number line. So if this is my number line, this solution is saying that x could equal 5. That's what this bar right here is telling me. And so I'm going to put a closed circle at x equal 5. 5 is a solution. And the solutions are also any number that is smaller than 5. Less than 5 or smaller than 5. And so I'm going to shade everything to the left of 5 in. So all of these numbers I've shaded in red are solutions to this inequality. Now, I really like using that closed circle to indicate that the 5 is included, but there is another symbol that you might actually end up seeing, and that would be a square bracket like this, and then everything to the left shaded. You can use either symbol. I don't care which symbol that you end up using. I'll probably stick with the closed circle, but I want to give you a heads up that you might see those square brackets. They mean the exact same thing. All right, example 2. I'm going to start by getting the x by itself, so that means I have to subtract 5. So -3x is less than 5. Then, to continue isolating the x, we have to divide both sides by -3. Now here's the one case where these inequalities are a little bit different than equations. Anytime you take an inequality and you multiply or divide by a negative number, you have to flip the direction of the inequality. The reason you have to do this is because notice if you have positive numbers, for example, we could say 3 is less than 7. That is a true statement. However, if I make those numbers negative, then the direction of the inequality flips. Now the -7 is actually smaller than the -3. So anytime you divide by a negative number, like in this case, I'm dividing by -3, I flip that less than symbol to a greater than symbol. So x is greater than -5/3. Now I'm going to put this answer on the number line. I'm going to graph this solution. To help me graph this solution, I am going to note that 5/3 is a mixed number, is 1 2/3. So I'm going to find -1 2/3, and I'm going to estimate where that is. This time, because I don't have that little line under the inequality, I don't have the or equal to symbol, I'm going to do an open circle. So I'm not going to shade in the circle. And then the greater than symbol means I have to shade in everything to the right. So I use a closed circle when I have that or equal to, and I use an open circle when I don't. Now the other symbol that you might see is you might see a kind of rounded parenthesis like this. That is equivalent to the open circle. I don't care which symbol you use. I'm going to stick with the circles in the notes. So example 3. Same process, we want to get the x's by themselves on one side, so I'm going to subtract x from both sides. And then to continue getting the x by itself, I have to add 6 to both sides. Finally, I'm going to divide both sides by 4. I am dividing by a positive number. The 4 is positive, so I don't change the direction of the inequality, and I'm left with x is bigger than or equal to -2. Finally, I'm going to put my solution on the number line. I have that or equal to symbol, so I have to do the closed circle. And greater than means we shade everything in to the right. Example 4. These equations, or inequalities, I should say, can get more complicated, But the great thing is the steps you take are the same steps we used with equations. So in example 4, I'm going to start by getting rid of parentheses. So I had to distribute the 2 and then distribute the 3. The next thing I'm going to do is combine like terms. The minus 6 and minus 5 gives me minus 11. Plus 6 minus 18 gives me the minus 12. Then I'm going to put all of the x's on the left. With inequalities, I really like to put the x's on the left. That is how you want to write your final answer. I want the x by itself, so I'm going to have to add 11 to both sides. To finish, I need to get rid of that negative in front of the x. That's actually a negative 1. So I'm going to divide both sides by negative 1. Dividing by a negative is going to flip the direction of that inequality. So I have a positive x. This flips to a bigger than or equal to positive 1. On the number line, I do a closed circle at 1. We are including the 1. And then greater than means I shade everything into the right. Now, just like our equations can have fractions, our inequalities can have fractions as well. And we're going to use the exact same strategy we learned a couple lessons ago. We're going to actually get rid of the fractions, or clear the fractions, by multiplying every term by the least common denominator. In this problem, I have denominators of 2 and 4, and so the LCD would be 4. So I'm going to go through and multiply all 3 of these terms by 4, or 4 over 1. That's going to allow me to actually do some canceling and get rid of the fractions. 4 divided by 2 is 2, and then on the right-hand side, 4 divided by 4 is just 1. So I'm left with 2x minus 12 is bigger than 3. And now I can solve this like any other inequality. I'll add the 12, and then divide both sides by 2. So I'm left with x is bigger than 15 halves, which is the same thing as 7 1/2. So I'm going to do an open circle at 7 1/2, and then I'll shade everything in to the right. All right, last example. Let's see if we can use the exact same process on this one. Now, because this problem has parentheses, I'm actually going to get rid of the parentheses first. That's typically the first thing I do with any equation or inequality, regardless of what kind of problem it is. So I get 2/3 times x, and 2/3 times 4 is 8/3. Now I'm going to multiply everything by the least common denominator. In this case, I have denominators of 3 and 6, and so that LCD is going to be 6. So every single term gets multiplied by 6. 6 divided by 3 is 2, and 2 times 2 is 4, so 4x is that first term. 6 divided by 3 is 2 again. 2 times 8 is 16. 6 divided by 6 is 1, so I've got a 1x, and finally 1 times 6 is 6. So now I'm going to put the x's on one side, and then I have to add 6 to get x completely by itself. And to finish, I'll divide both sides by 3. So my answer is x is less than or equal to 22/3, and 22/3 is the same thing as 7 1/3. So I'll put a closed circle I'll estimate where 7 1/3 is, and then less than or equal to means we shade to the left. That's it for this week. As always, let me know if you have any questions on this material.